Welcome to solverfy.
Okay, so we have to decide whether the proposed Lewis structures are reasonable. First, we have a carbon doubly bound to another carbon with two hydrogens, and then a carbon with a double bond to the carbon behind it, one bond to hydrogen, and then a carbon with a single bond to hydrogen and no other bonds. And overall, it has a 2+ charge. Now, the context by which we're determining if these are reasonable Lewis structures is given in the document title, which is Evaluating Octet Compliance at Carbon. Octet. Right, so what we're trying to determine on each of these is, do the carbons follow the octet rule? What is the octet rule? Well, for carbon, that means that you need to have exactly 8 electrons around it. That could be all lone pairs, or more typically 4 bonds to carbon, right? We don't actually often see lone pairs of carbon, though it is possible. So for each of our carbons, we need to ensure that it either has 4 lone pairs or bonds, or a total of lone pairs and bonds that add up to 4. And we can see this first carbon has 4 bonds, the second carbon has 4 bonds, and the third carbon, though, it only has 2 bonds, right? So that carbon is not obeying the octet rule. So based on the criteria given, this is not a valid Lewis structure. Let's move on to the next one. Now we have a central carbon with 2 bonds to nitrogen. That nitrogen has 2 bonds to hydrogen and a positive charge. And that central carbon has a bond to a CH3 and another CH3. And what we can see if we look at our carbons is that this carbon has 1, 2, 3, 4 bonds. The central carbon has 1 bond to the left, 1 bond to the right, and 2 to the nitrogen for a total of 4. And that this carbon has 1, 2, 3, 4 bonds as well. So everything is fine in the second Lewis structure. This is reasonable. Let's look at our next Lewis structure. Okay, now we have a carbon in the middle with a bond to an oxygen. It's bound to hydrogen that has 2 lone pairs. On the oxygen, down to the left is a CH3. Like so. CH3 again. And then we're given a positive charge on the central carbon. And again, we're asked to determine whether this is reasonable or not based on evaluating the octet compliance of carbon. Carbon, again, the CH3 with a bond to the central carbon, that has 4 bonds. That's all good. The one on the right, 4 bonds. That's good. But our central carbon has only 1, 2, 3 bonds. That is no good. This is not a reasonable Lewis structure. And our final molecule has 3 carbons in a row, each bound by a double bond, and the terminal carbons each have 2 bonds to hydrogen. Okay, and we can just go through here and count how many bonds does this carbon have. 1, 2, 3, 4. Looks good. How many bonds does the central carbon have? 2 bonds to the left and 2 bonds to the right. That's a total of 4. Right. And the one on the right, again, is the same as the one on the left, as 1 bond to hydrogen, 1 bond to hydrogen, and 2 bonds to carbon for a total of 4, which means that this is a valid structure.